We are looking at the tail end of the chapter of light. That's why our learning objectives are just these four. In this video, I will be focusing mostly on the first three. The next video will be on this last one over here, describing the characteristics. Now, we have just finished the section concerning refraction. And one of the examples of refraction is the use of a prism. And the way the light bends in a prism is actually pretty interesting. So here we have a very badly drawn prism. Let's say I have a light ray that's entering in this direction. Now you would ask yourself, what then happens? Remember that this is air and this is glass. So this is a more optically dense medium. So how would it bend? I would first have to draw my normal. Remember, my normal has to be perpendicular to the surface. This would then bend toward the normal, right? Something that looks maybe like this, correct? And now once again at this point over here, our normal is now here. Please note that normal is not this way. Look at the surface and look at your 90 degrees to that surface. Once again, let's put on our normal. And now that it's moving from more dense to less dense, more optically dense to less optically dense, I know it's going to speed up over here. So it will bend away from the normal, something like that. Which is pretty interesting because I can see that because of this, the way the glass is formed here, my light actually bends and goes this way, right? Now, when we look at the lens, right, a lens, actually, if you would break it up into different pieces, a lens over here, right, will have a section of like a prism over here and a prism over here, and all the other parts of the glass would act like the prism in how they bend light in a certain direction. Now, this part of the chapter, we're looking at the thin converging lens. What is a converging lens? A converging lens is basically something whereby when you shoot a light ray, it's going to converge or it's going to come together at a certain point. So for this reason, we need to do a couple of definitions. I'm going to be putting the picture that you see inside your textbook, and we need to do quite a few labeling. So here we go. Let's move this up a little bit. When we are drawing our lenses, what we want to do first is that we say that, hey, I have a lens and my lens is in a certain location here. Okay? Later on, we're going to change from drawing a lens like this, like a teardrop, to looking like this, because this is a sharp pointy part over here. There's a sharp pointy part. And I will want to know where exactly is the middle, which we'll see later on. And I can do the same thing just by drawing this double arrow over here that represents my lens. We'll get to that. Now, for me to find some form of orientation, I would need to draw something that looks like an x-axis, right? So that I know where I'm going. So I'm going to draw a line right across the center, something like this. All right? Something like that. Now, I'm going to call this not my x-axis. I'm going to call this line, right, my principal axis. So that's really the line that passes through the center of the lens right here. Sorry, not drawn very, very well, but this is the center of the lens. And it's perpendicular to the plane of the lens, all right? Because remember plane, we actually talked about plane when we use reflection. We talked about how the angle of incidence, or rather the incident ray, the normal, and the reflected ray all lie in the same plane. That's the same idea over here. Now, what do I call that center position, that center point? So if I were to just mark this with a red X over here, we're going to call this point, right, the optical center. What's special about the optical center is pretty much like what we did when we were doing those experiments in class where we have our semicircle block. And we did say, especially when we were talking about how total internal reflection occurs, we said that as long as my light ray hits the center, correct, or points towards the center, right, nothing gets refracted as I go from air to glass. Let's zoom in a little bit. Let's zoom in a little bit over here just to recall what we said. So this over here is a center right here. Okay. Now, if I were to have any light ray pointing towards the center, like this. So let's say the light ray enters here, is from the air going to the glass. As long as I point towards the center, right, there is no refraction that will happen as I go from my glass to air, because the special property of this semicircle glass block is that when you do that, right, it enters perpendicular to this glass block. So like you know, refraction only occurs when you enter the angle, correct? When this is 90 degrees, when the angle is 90 degrees, it really does mean that the incident angle is 0, right? So there's no refraction as it goes from here to here. Can you see that? It's a straight line. Now let's see if we can understand over here what we know about the principal optical center, right, which is here. As long as the light ray enters and passes through here at the center, right, it does not get refracted at all, right? It will continue as a straight line. So now let's look at what we have on this side over here. I am now going to introduce a number of light rays that come from very, very far away, and they're all coming in straight, parallel to my principal axis, right? So imagine like a giant spotlight from far, far away, and the light is coming this way, right? And I'm not just using just one ray, I'm using a number of rays. So out of the infinite number of rays, let's just choose these. Okay, later I'll scale it down to 3. When they all come here, what happens to the light rays when they enter this glass block? So let me recreate it on this side. If I have, let's use another color. So I have one light ray that's coming like this, right? Hits here, another one like this, and another one like this, correct? Now, I know, oops, something's wrong with my diagram. As a ray diagram, I must have it, not just a straight line, but I also must have direction. Please do not what happened? Please don't forget to draw it with the arrows. Now, this one over here, because it's going through the optical center, there will be no deviation. It will continue to go on straight. Nothing is refracted. I'm sorry, I'm trying to get my ruler to get it just nice. Something like that, right? So it goes on straight, does not bend away or anything like that, it goes that way. But I will see, right, as we did in our class, for this converging lens, this over here would bend downward. It converges, it will bend inward this way, that light ray. And the other light ray over here would bend this way. You can tell that my ruler skills are really lousy. I am so sorry. I am still not drawing. I'm still adjusting my ruler. Just not working. Yeah. Okay, something like that. Right? So this is a light ray, this is a light ray, and they all bend towards this point over here. What do you call this point? It is where all the light rays seems to focus, correct? This over here becomes your principal focal point. That's where we are over here. Right? Where do you find this principal focal point? You find it along the principal axis, that x-axis that we used, right? So this over here, I need to mark it with a capital F. That's my principal focal point. That's where all my rays are focusing on. Nice. Then we have this very, very odd thing that says focal plane. What on earth is that? Well, put it this way. Do you realize over here we're having all the light rays just going absolutely parallel to my principal axis? What if it's not parallel to my principal axis? What if it's coming at an angle and they all come at an angle? Okay, so I'm not going to draw here anymore. Okay, let's focus on this part over here. Let me move the screen this way. See, if everything was still parallel this way, coming towards my lens, where does it focus? Well, let's look first at that line that passes through my my optical center. This line that passing through my optical center will not get refracted. It just keeps going straight, correct? Oh, it's hitting here, correct? Now, every other light ray will now have to bend towards my, is that focal point? Is it up here? No, not up here. To this other part. What is it over here? This is another focal point. How do I use this though? Well, let's put it this way, okay? The principal focus, it is along the principal axis when everything was going parallel. And I know it's going to be here. There's something else which I must measure. And this is a part that's actually tested. I need to know my focal length. Focal length is simply from here, from my optical center to my principal focus. So it's just this part over here, this distance. That's my focal length. So where is my focal plane? That focal plane is basically, right, that line parallel. Oh, sorry, not parallel, sorry, perpendicular. Oh, it's right here. Perpendicular to the principal axis and from my focal point, right? So this focal plane is all the possible focal points you get when the light enters at different directions, right? This is a focal point, this is a focal point, this is also a focal point, but this over here, which is along my principal axis, is called my principal focal point, capital F. This is very important because we're going to use this point as we draw and as we make all of our ray diagrams, right? So what do we know so far? I know one. When I look at my lens, I'm going to realize that anything passing through the center will not bend, will not have any refraction. Everything else will, but where do they refract towards? Where do they converge? They will converge toward a point over here, which is along my principal axis, and that point is known as my principal focal point, capital F. Now, usually in the questions, right, we just call it focal point. Boom, here, capital F. What must you be able to define? I must be able to define what is my focal length. This is small f. Focal length is just the distance between my optical center and my principal focal point. If I had to change the direction of these pointing in another direction, they would converge somewhere along my focal... Ooh, I didn't draw it properly. Again, is that better? My focal plane. They will all converge somewhere along the focal plane. There'll be another focal point there, but the principal focal point is right here. All right, that's it. Let's now start to draw and see what happens. How do I get an image when I put an object at a certain distance in front of my lens? Now here we get into the actual drawing of the ray diagrams for our thin converging lens. What we want to know is that when we draw it this way, this double-sided arrow, is that correct way of saying it, represents our lens. All right. Now, what on earth are these four lines over here? Well, let's look at it. We are going to now put this as F because that's the distance away from my optical center. And twice that distance is just literally 2F. Now, understanding that light is reversible, that means if light goes from me to you, the light goes from you to me, right? There's a reversibility of light in terms of direction. So if there's F and 2F on this side, there's also going to be F and 2F on the other side as well. And 2F. Now, what we're going to do right now is we're going to put an object, okay? We're going to put an object at a certain location on this side of the lens, and we're going to see how the light rays that come from that point, from one of the points of this object, where will it appear, and can we describe the properties of that object? So I'm now just going to draw an arrow over here. Now this arrow is just representing an object. The reason why we have an arrow is because you'll see later, right? If I start my tip over here, if I start for all the light that comes from the tip, where it comes, where it will form later on would be the exact location of the point of the tip of the arrow of the image. Let's try first, and then we'll see, and we'll try to understand more as we do it, okay? So once again, this is my object. Light rays could be reflecting all over, but I'm just going to choose the point up here. Let's have 3 lines. Now, the 3 lines I want to have is a light ray that originates from the tip that goes firstly right through the center, right through my optical center. So it looks something like this. Light ray going this way. Now, I need to draw one arrowhead here, one arrowhead here. Okay. Let's do one arrowhead on each side of my lens. Let's draw 2 more, or actually minimum I just need is actually 1 more. I want to have one of the light rays that comes from the tip of that object, one that goes straight, one that goes parallel to my principal axis, something like this. So like what we did just now, the question is, if I know that this is traveling parallel, right, to my principal axis, where will it go now? We know that it will converge, it would go down, and it will pass through my focal point. So my focal point is going to be one whereby it's going to bend downwards, something like this, right? There. Now, what's interesting is that all the two of these light rays, one here, one there, they have converged at this point over here. Now, does it mean this is my focal point? No, I'm just saying that the convergence, this over here is my focal point. The light rays need to pass through the focal point, except when it's going straight through the optical center. Now I can do one more. I can do one more ray, which is kind of like the opposite of this. Correct? What if my light ray goes from here through the focal point first? What will happen after that? See, if this went parallel, I went through the focal point, I could do the reverse, right? I could have a light ray that goes through the focal point and then go parallel. Exactly, right? This is the whole idea of the reversibility of light. So let's see what happens when it goes through the focal point first. Okay, I hope this is gonna be okay. Something like that. Now, where will it go now? I said now twice, I know. Now it has to go parallel, correct? Parallel will be somewhere like this. Right? Please excuse my poor drawing on my iPad. If it went through the focal point first, after that will come parallel as it exits over here. So now all three of these have now come to a point. It originated from the tip over here. Oh dear, that was not really drawn very well. Hey, okay. All originated from the tip over here, correct? So where the light rays are going to meet, it will now be the image and it will be the tip of the image, isn't it? So I'll draw once again, just like that. It will be the tip of the image. And the rest of it would follow this way. Right? So let's see what we have. I have my object. I have my image. Right? Everything came from the top of my object. I would have this part of the arrowhead. So this is going to be the image where it comes out on the opposite side of the lens. What is interesting is that I can now shift this object to different locations along this part of the lens, and we're going to see what happens to the image. We're going to see different types of images formed, and with different images, we're going to see that I can describe them according to my diminished or magnified, whether it is upright or inverted, whether it's virtual or it's real. So what's supposed for, oh, sorry, I'm mixing my words. What's the most important thing you're going to learn from here is how to draw this. You're going to know that if we first start from the top of the object, draw one straight line through that goes through my optical center, it will be one straight line. Draw another one that goes parallel to my principal axis and then through the focal point. Where those two meet, you're going to find this is where my image is focused. There's focus on one point, this is where my image will be, right? And I can see that compared to my object, this over here is diminished as compared to magnified. Is it upright like this one? No, it's inverted, not upright. And do the light rays really meet? Yes, the light rays really meet. This over here is a real image. Now, this is further expanded upon in the next video, but this is supposed to show you how to draw a basic ray diagram. I'm just going to show you one more drawing. As we draw, I want you to figure out where it should go and guess where it's going to go. All right, so let's try this one. After this diagram, we're done. All right, so now the question is, how would you draw the ray diagrams? How would you complete the ray diagrams to figure out where is the image? This over here is my object. Where's the image? What is the first line you will draw? The first line I will draw is the one that goes straight through the principal optical center. Sorry. Something like this. Okay, so that's the first line I draw. I remember I must draw my arrowhead. The next one I'm going to draw, I prefer the one that goes parallel first. So I'm going to start from that same tip, parallel to the principal axis. I'm going to draw it straight across to the lens. Why is my pen not working? Right? Goes this way. And then now this has to go through my focal point. Please remember, I need to go through F after I hit the middle of my lens. And it will look something like this. Ooh, there you go. Can you imagine what my image will look like? So this over here is the part where it meets, correct? So now I need to draw that tip of the arrow there. So let me try using my ruler. I'm going to draw it like this. And my tip is over here. Right? Can you see how that works? So let's check in on a couple of things. I started with the straight line that goes through my optical center, or kind of in this way. I have my arrowheads for this first one. Then I drew one that's parallel to principal axis, and then it went through my focal point. And then they met here. They met here. The light rays actually met. So could you tell me what are the properties of this image? Compared to my object, this is bigger. So this over here is magnified. Where is my marker? Magnified. Secondly, what else do I see? Is it in the same direction? No, this is upright. This is inverted. It is inverted. And finally, do the light rays really meet? Yeah, they do meet. So this is real. Ooh, there's one more drawing to know. You can realize that as I bring this closer and closer to my lens, it's getting bigger and bigger, right? What happens when I put it right next to the lens over here? This is a special location which is between F and the lens, right? Or rather, I just realized I should put it this way, I should say it this way. This over here is my object distance, correct? This over here is my image distance, correct? Now, if my object distance is going to be less than F, something happens. I will have a drawing that seems a bit odd. Okay, so let's get to that. All right, now let's position the object right next to the lens where the object distance is less than F. F meaning this distance over here. All right, what if it's less than F? What then do we do? So let's do the usual things. Let's start off first with one line that goes right through my optical center. And you're going to realize, something looks a bit funny there, right? So from here, goes through, okay, here and here. And the next one is supposed to be one where it goes parallel to the principal axis and it will go through the focal point. Okay, here and then to the focal point. Then you go, oi, they don't meet leh. How? How? So this is what we're going to do, okay? We're going to now extend the rays because the light rays have to meet somewhere, right? So let's extend the rays backwards, okay? So I have a dotted line over here because the light rays aren't really going there, correct? The light rays clearly are supposed to be going this way, but let's extend it backwards, okay? Likewise, let's do the same thing for this ray over here, okay? Let's extend that ray backwards as well. And then we're going to see something that looks like this. Now, this seems to be a point where the light rays seem to meet. Are they really meeting? No. This is the dotted line backwards. What we do say that, similar to what we did before, up here, let's put the point where the light rays seem to meet. This is where my image will be. So, because this is not where my light rays are really at our meeting, I cannot use a bold line. I need to use a dotted line because it's not really there. Similar to what we did last time when we do for mirrors and we have a image which is virtual. I now have a virtual image, right? And the idea is if they don't meet over here on this side, try extending backwards and see where they do meet, right? In terms of explanation, we'll go through more of that in class, but this is just the method in which you're going to solve the questions where they don't meet, then go backwards, right? And you see this point that they meet over here? This is where my image will be. And now if you describe this image, right, is this magnified or inverted? Is this magnified or diminished compared to this? This is magnified. Is it upright? Ooh, it's no longer inverted, right? They're both upright. But in this case, this is a virtual image, right? So these are the ways to solve the questions when it comes to drawing. You need to know the main ideas, which is, once again, I say one time, like a naggy person. From the tip, go through the center, it's a straight line. After that, do one parallel line that goes straight and then through the focal point, right? Most of the time they should meet. If they don't meet, go backwards. It's probably you're going to get an answer where the image is virtual. Okay, now we're done. Thank you very much for your attention. See you guys soon.